All right, we are going to take a look today at our mini unit here before we get rolling into more material of our quiz preview. So, as we take a look, a couple things to notice. One, notice there's section numbers with each of these, so if there's something you're specifically having an issue with, great opportunity to be able to go back and either look at the notes for that or maybe type in the video in the search in either my YouTube or my website and get some extra help. But for right now, let's take a look at these first two sections here and see how they overlap. We're going to write from exponent to radical and radical to exponent. So remember, when we're looking at these, we talked before about how if we were looking at something in an exponent form, that it would always be exponent over root. And then if I was looking at it in its radical form, I just have to remember again that I've got my exponent and my root, and I have to be able to go back and forth with those. So when I look at one like number 1, I look at that and I go, okay, write each expression in radical form. So I'm trying to get to this. Whatever's in the parentheses, or whatever my base is, that goes underneath the radical. This is going to be my exponent on it. I'll keep my parentheses there. And this is going to be my root. Now, some of you may be wondering at this point, well, wait a minute. I thought we assumed the exponent was 1. I thought we assumed the root was 2. So do I even have to write those, or could I just write it like this? Either one's acceptable because they're telling me the same thing, because you're right. We do assume this has an exponent of 1 and this has a root of 2. So if it's those two, you can do that. But if it's numbers, it's a good habit to be doing it this way. Speaking of that, if we look at number 2, exponent over root. That's all I'm doing. I'm not solving anything. I'm not doing anything fancy. Just rewriting it into its new form. And then I'm going to do the exact same thing when we get to exponential form down here. Now again, here I do have to remember, oh yeah, that's a 2, and this would be a 1. So if I'm writing it in exponent form, my exponent's 1, my root is 2. Now the question here may be, do I have to have the parentheses? And the answer is yes, and here's why. Both the 7 and the x are underneath the radical. Okay, it's not just one or the other. So this whole thing is being taken to this exponent and this root. If I didn't have the parentheses here, the 1/2 would only be going to my x. So if I wrote it this way, the 1/2 would only be going to my x, which isn't true because they're both underneath the radical. So that is not what I want. This is. Okay. And then the same thing here. Oops. We're going for exponential form, Harty. Rewriting it again as a radical does not help us. Whatever's underneath, even if it was just a plain variable and you put it in parentheses, that'd be okay. Exponent over root. And I'm set. Simplify, or in other words, answer it. Okay. So let's see here. Is the calculator going to be more helpful here? We're going to find out. We definitely don't need that. All right. 625. Here's the key. I'm going to do this on here for both of them too. Gotta have the exponent in parentheses. If I don't, oh boy for me. And that's all I've got to do. You're like, all I got to do is remember to punch in the calculator? Yeah. There are some other ways we could do it, but I know and you know we like to find the simplest way of going about things. And being able to have a calculator that'll help us out with that is not a bad thing. So I'm going to go ahead and I'm going to do that. Now, back into our rules with simplifying and doing exponents. Again, this is where you've got to go back and look at things. For these first couple even, 6.1 can be helpful with notes too. You've got to know them at this point. You've got to know that when you're multiplying with exponents, you add them. Okay. When it's power to power, which means it's exponent to exponent, you multiply. When we're dividing, subtract the bigger one from the smaller one, and the answer always goes where the bigger one's at. And if an exponent's negative, you've got to flip it to make it positive. Those are the rules, okay? But again, these only apply on exponent rules, not on my base values, not on coefficients. But again, they're in the notes twice in both of these sections. So again, if you need to review that, go back and do that. Or I even have like a mini review I could give you that has some examples on it too and talks about this. So do keep that stuff in mind when you're doing this. And again, if some of you are struggling, I have this little mini packet that goes over the rules and gives you some examples and then gives you some extra practice problems on the back of it. So if you'd really like to be able to re-look at some more of these and get some more practice, just see me and I can get you one of those. Okay, back to the time being though. Simplify. Exponents. Multiplying these together. I need to add them up. Now again, if fractions are not your friend, we do not use mixed numbers for exponents. You can't put 2.5, I'm sorry. Now, if you're like, well, I know it's 2.5. Oh, can I just turn it into a fraction form? You sure can. Well, what if I didn't know that? Is there a way I could do it in the calculator? Sure. I can still do 1 divided by 2, my 1/2. Add 2 and no decimals. And still get the answer that way too, okay? So you have lots of options, you just have to know the rules to be able to use that. Power to power, we're multiplying. 2 times 1/4, again, if you know that off the top of your head, super. If you don't, 2 times 1/4, 0.5. You're like, oh, 0.5, that's just a half. Right. And then 1/4 of 4 is just 1. Keep it simple. Just because it's a fraction doesn't mean it has to cause a problem of any sort. Okay? Then it goes over to the radicals. Reminder again. What's the little root number here when I don't see it? Hoping somebody said 2 at this point. Then I just look and I go, okay, the square root of 36 is 6. Punch that in the calculator if I'm not sure. And then remember, it's old school division here. Reminder, back up to the top. Exponent divided by root. Exponent divided by root. But what is 4 divided by 2? It's 2. I'm done. Okay. The same rules apply here. It's kind of cool the way they keep coming back to the same place, but I got to know the rules to get there. Okay. Cubed root of 128 n to the 4th. You're like, ooh. Couple of things that are kind of strange going on here. Now, remember, we talked a bit before about how I could turn something like, so I've got 128. Remember, it does have an exponent on it. And then I've got n to the 4 over 3. Now let's talk about both of these. Let's see first what I can have with my 128 to the 1/3 here. Okay, if you get something in this case that doesn't break down nice, since our theory right now isn't breaking down other stuff like we did first semester, I'm actually going to let you get away with something here. Okay, I'm going to let you keep the 128 underneath if it doesn't break down nice. If it does, like I did with 36, we take it out. But remember, with the exponents, we go to old school. We go to long division. We say, okay, so I'm doing 4 divided by 3. How many times does 3 go into 4? Once. So that is my exponent on my variable outside the radical. Whatever's left over, whatever my remainder is, that's inside. So however many times it goes in whole, goes outside the radical. And however many times it is here, is going to be inside my radical. And that's all I can do. If some of you are really kicking it up and you can break down the 128, okay, which would be 64 and 2, I say go for it. But otherwise, for now, I'm just testing those exponent rules to see if you know where everything's going. To the back, look at our roots here. Identify the domain and range and sketch the graph. Now remember, we talked about our parent graph. When it's a square root, it's the perfect squares less than 10. I look at my base graph. I go, oh, square root of 1 is 1, 2, 3. And remember, we plot those points. Now again, I'm going to have a secondary option here for you in a minute. So just be patient. If that's not something that clicked for you before, that's okay. But I do have to understand my shifts. What are my 2 shifts that are going on here? We're heading left 3, because this is always my left and right shift, and up 3. So for each of those points that I already plotted, I'm going to go left 3 and up 3. Okay. Arrow only on one end. These don't go forever. And again, my domain and range, there was even a nice, easy way to remember this. The domain doesn't change on these, okay? My domain and range, where's that first point going to be? Well, my first point here is at -3, +3. These directly correspond to my domain and range. My domain starts at -3 and heads forever to the right, so -3 to infinity. And my y values start at +3 and go on forever. Now again, some of you are saying, I thought you said though we could do this on the calculator if we didn't get something. You absolutely can. So what we're going to do is we type this into the calculator. So second and x squared gets me there. Whatever's under the radical, we keep in the parentheses. So the x plus 3, I gotta close them though. If I forget, not gonna get the right answer. So we can look at the picture. Yeah, it kind of looks like the one I have. And then again, if you look at your chart, the error will tell you where you have to start. The first number after, check that out, -3, 3, just like I had here. And I can get the exact same points, -2, 4, 1, 5, 6, 6 that I had if I did my base graph and shifted them. Either one works. I don't care. As long as you do the domain and range, okay, and get your graph right, that's fine with me. But I'd write down the shifts too just to be sure. Same thing when I get to number 12. Now this time though on number 12, I have a little bit of a change. I have a number in front. I have a coefficient in front of my radical. That's going to change my base graph or my parent graph if I'm going to do it that way. These values don't change, but now every one of my y values gets multiplied by 2. Multiply 0 by anything, you still get 0. 1 times 2 would be 2. 2 times 2 is 4. 3 times 2 is 6. So I'd get those. It stretches my graph more. And no, it's not time to go. I'm just doing this during lunch. Then I'd look at those and I'd say, okay, what's my shift here? It's under the radical. It's left or right. Oh, the minus is right. Right 2. So each one of these, right 2, right 2, Right 2. Oh, we're getting way out now. Right 2. Look at that. I say, where does my graph start? It starts at 2, 0. So that's going to help me with my domain and range. My domain starts at 2, goes off to infinity. My range starts at 0, goes up forever. And again, I can do it on the calculator. Swing this over here. I can just punch this in. I put the 2 first, then my square root, and everything that's left is underneath the radical. So I go ahead, I put it in that way. 2, 0, there's my first point, just like it was here. Okay, 3, 2, and I get all those points that I need. It's totally preference of what you want to do on those. And the only difference when we get down to 13 and 14 then becomes that it's a cubed root. Makes my base graph a little bit different because now I'm looking at my perfect cubes, which is 0, 1, and 8, but with cubes I can also do the negatives. So again, these were my parent graph numbers when I was looking to do these originally. So I'd plot those points. Again, that's not the answer, that's just where my original points would be. And then I'd do my shifts. And my shifts work the exact same way that they did up in 11 and 12. This is my left-right shift, but it's the opposite. So I'm going to move a left 4. But that negative means it's going to be down. So if you do these points, I go left, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and this guy is 1, 2, kind of way out here. Arrows on both ends. Cool thing with cubed roots, always goes forever left and right. Huh, coincidence? Not really. Range goes forever left and right, but that's only on cubes. So you get off a little bit easy as far as that goes. And then 14, we're similar to like what happened in number 12. I do have a coefficient, I have a multiplier this time. So my parent graph numbers are going to change a little bit. Not the x's, but the y's are all going to multiply by whatever this number is, by 2. So negative 2 times 2 is negative 4. Negative 1. Oops, I didn't do the last one on the calculator. We'll do this one on the calculator. Negative 1 times 2 is negative 2. 0 times 2. And then we just multiply all of those. So I get those plotted. Again, I notice it kind of stretches my graph out when I have that number in front. And then I look for the shifts again. Plus underneath means we're going left 4. Still not leaving, I know. Jeez. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 2, 3, 4, 1. 1, 2, 3, 4, 1. Way out now. 1, 2. And again, these arrows on both ends, unlike square roots, these do go forever. And I get my domain, and I get my range. Now, I said I'd do one on the calculator, and I didn't do the last one. So we will do this one on the calculator. Here's what changes on this one. There is a way to get to a cubed root button. Okay? But for most of you, the more button presses there are to remember, you forget and you get irritated with things. So here's my suggestion instead. If you've got a cubed root of something, so I look at this and I go, okay, I've got the cubed root of x plus 4. All I have to do is take the x plus 4 and take it to the 1/3 power. So x plus 4 1/3. Okay? But then, don't forget, I still have this minus 1 at the end. But I had to close the parentheses before, because this 1/3 power only goes to this portion right here. Look at my graph. Yeah, looks about the same. Okay, I don't have error messages to tell me things this time, but I still should see numbers that are helping me out. -5, -3, -4, -1, 3, 1, okay? So just like before, you can still type it on the calculator and get all the points that you need to be able to make that work. You just got to remember this to the 1/3 power. And then finally, what we've been working on these past couple of days, okay? Solve each equation. Remember to check for extraneous solutions. We'll talk about that in a second here. Remember, we want to make sure, when possible, to get the radical by itself. So like here in number 15, I need to add 5 to each side first. Once I do that, what's the inverse, or what's the opposite of square rooting something? Squaring it, because remember that little 2 is here, so we're going to square both sides, because the square and the square root are inverses. So it just gives me what's left underneath. 9 squared. People, I'm going to say this again. If you don't know what 9 squared is, do not try to be a hero here. This is not the time for that. If you don't know that 9 squared is 9 times 9, punch it in the calculator, okay? Terrible to get this far in all this work and then have something go wrong. Once you get here, I have my Algebra 1 equation solving experts. I minus my 9 over, and I divide by -9. Now, here's what you're basically doing to make sure when it talks about extraneous solutions. What's that mean? It means the answer doesn't work. Basically, here's what I want you to check for. No negatives for answers under the radical. So like if I were to plug in this -8 and I got a negative number under here, I can't take the square root of a negative number because I'd need to take an I out. Well, we're not dealing with that right now. But that's not a problem here, because -9 times -8 is positive 72. 9 plus 72 is 81. That's going to be okay. That's all I'm really making sure doesn't happen. I don't want negatives under the radical when I'm done. Okay? What if I had radicals on both sides? Not a problem. In that case, as long as it's only 1 per side, we'll square it, which just gets rid of the radical. Go ahead, get that out of there. And now I'm just doing some algebra to get set. I don't like negative variable terms, so I'm going to add the 2k. Remember, there's a 1 here. Don't forget about that. I'm going to add 2 to the other side, because again, it's all about getting k along. So if I add that 2 over, it gives me 15, and I divide by 3, and I quickly make sure it's not going to make a negative underneath. 2 times 5 is 10. 13 minus 10 is 3. That's okay. 5 minus 2 is 3. That's all good. I don't have a problem. So we're just making sure on that. Now 17, we have options. We're going to have options for 18 as well on what we talked about yesterday. I'm ready to square right away. Now, at this point, I'm going to do it algebraically, then I'm going to show you on the calculator. V squared, those cancel. On this part, everybody wants to be on the v squared side. V squared is where the party's going on. So, these guys both want to the other side. So again, I have to do opposites to get them there. Because I want the one side to be 0. I want all that stuff gone. And then over here, I get my expression. Now at this point, I have to be able to Algebra 2 F-word this. I need to be able to factor. So I look and I go, oh boy. Multiply to 100, add to negative 20. Now again, if this is not your strength, and it's going to have to be sometime during the semester because we've got to be able to do factoring in some cases. I want you to take that 100, and if you're not sure, I want you to take that and I want you to start taking numbers and start dividing them in, and I want you to make a list. Okay, so 2 and 50. I tried 103. Nah, that didn't work. 104. 4 and 25. Now remember what I'm trying to do as I do this though. I'm looking for the pairs of numbers that'll work out nice, but I'm looking for a pair that's going to get me to 20 on here. So I'm looking and I'm trying some and I'm going along. I'm going to fast forward a little bit here to make it a little bit easier for us to be able to get there at the end. And here's what I know. I know since they multiply to get a positive and add to get to a negative, they're both negative. And since they're both the same sign, I'm looking for two numbers that add up to 20. 2 and 50 do not add up to 20. Nope. Nope. Ooh, those do. And then I just set those equal to 0. Now since they're the same thing, I don't have to do it twice. I do it one time. And I get my answer. Okay? What if factoring is not my thing? Is there a way just this once that I can avoid it? Yes. Okay, here's how this is going to work. I'm going to take my two sides of my equation. Now I don't have a v, so I'm going to use x. And then over here, I've got the square root of negative 100 plus 20x. Okay, typing on separate lines. I'm going to look at the graph of it. Now I notice they intersect somewhere up here, and that's what I'm looking for. So again, to find the intersection, I do second, trace, go down to intersect because I want to see where they cross. And here's the cool thing about intersect. You don't have to do anything fancy. You hit enter one time, two times. Once I get, oops, I got to get over to my second curve where I can see the little blinky guy. I got to see a y value here before I can get him going. So I'm going to keep going right until I get up. There we go. Enter. And then enter for my guess. And the intersection, okay, and again, I'm looking for the x value. That's pretty darn close to 10. And I'd write that down because if we round it off, that's what it would be. So let's do that on 18. Okay, we'll do the graphic way first, and then we'll do it the algebra way and see where we're at. So let me clear these out. I'll type it in. So 17 minus 2x, close that up, and then x minus 7. All right. I see the intersection point. So second, trace. I want the intersection. Okay, I see my blinky guy. I have x and y values, so I can just hit enter. Again, I see my blinky guy. I have x and y values. I can hit enter. And one last time. And it tells me the intersection's at 8, 1. But remember, I want the x value. Okay. And I can just do it that way. I would very much suggest doing it that way. Because if you don't, and I'll write it down here, but you're going to look and go, oh my gosh, that's so much work compared to what I could just do here. And you're right. If I square both sides of this, I also have to square or box this out. I can't just distribute that through. I have to do x minus 7 and x minus 7. Now, if you think back, that means I'm going to make a little box. You're like, Harty, I could have been done with this problem already. I mean, with what we just did before. I know. That's what I mean when I say if we take the easier way of doing it, it's going to make life simpler. Because now, I got to do what I did back in 17. I got to get everything to the x squared side. I got to add 2x over. I I got a minus 17 over. And now I got a factor. I'm not even done yet. Again, we'll fast forward a little to kind of let us see what this would be. And then I set those each equal to 0. You're like, but wait a minute. You got 2 answers this time. Remember, no negatives for answers. Okay? Here, 4 minus 7 would be negative 3. Can I take the square root of a negative number and get negative 3? No. Another bonus in doing it by the graph, because you won't have that happen to you. You won't have to worry about that. Okay? Quiz tomorrow, similar looking to this. Work through this stuff, practice it, go back and look at sections if you need to, go back and look at videos from those sections. Shoot, just watch this again if you want a little bit of everything. But be ready, be ready, be ready, and have your homework done. We'll see you then. Good luck.